Good morning, squad. Mr. Herr here. We're on page 136 and 137 in your books. Ideally, we'll take a little bit of notes and then I'll cut you loose on pages 138 and 139. All right. Yeah, so you should be following along, whether it be on your phone or on your iPad, and then jot this in your notes. So, what is E? We're going to be talking about this a lot when it comes to interest. E is the base of the natural log. If you're saying, what the heck's that? Don't worry, we'll talk about it in a moment. And more specifically, for our purposes, E is used in continuously compounded interest, which is what we're going to really focus on when we're finding our interest rate. Nice thing about that, we can just type it in our calculators if we know how. Okay, so it says evaluate the following: e to the fifth power. Hopefully you have a handy dandy yellow calculator. If not, run to the back of the room and grab one. Okay, I'll turn this thing on. First, let's talk about where you find it. We press second, and then we press this LN button. And notice it says right there, e to the x. So that will bring up e to a power. Well, it's just e to the fifth power. Just hit it and go, 148.41. Sweet, okay. Even on problems that are more complicated, like 1,000 e to the fifth, 10,000. Okay, you literally just type what we have. So it should look an awful lot like that. Look at what we typed. Is that what we have? Yep. Sweet. Okay. No, I won't do all these together with you right now in the interest of keeping the video short, but I will kick the answers to all these if you're panicking. Okay. What is natural log? Natural log, if you want to get specific, it's the logarithm to the base of the mathematical constant. For our intensive purposes, it's the inverse of e to a power. If you're saying, what do you mean, old man? Sorry for bad power there. So if we take natural log of e, we type it in exactly the way it looks. Sorry about the glare, so I'll slide it over. Natural log of e, and that's to the first power. If it's not written, it's implied to the first. Boom, it's just going to give us 1. What essentially happens here, the natural log and the e cancel, and you're left with your power. What I mean by that is, let's look here at C. Natural log of e to the 8th. Okay, well, if it cancels our e and we're left with the power, natural log of e to the 8th should just give me 8. In fact, it does. Okay, so even when it looks complicated, like here in F, okay, 27 natural log e to the 8 times 0.10 power. Jeez, that looks way scarier than it is. What is it going to do? Those two will cancel. 8 times 0.10 is 0.8 times 27. Oh, 21.6. Okay. Really is that easy, right? Calculator based. Let's keep rolling. Okay, so if we're evaluating here, this is where it gets a little more complicated. Evaluate e to the x power. Remember what we said previously, natural log is the inverse. So what I'm going to do is I'm going to take the natural log of both sides. That means the natural log of e to the x equals the natural log of 3. Remember, natural log and e cancel each other out. They're inverses. That's what it means to be an inverse. So this is x equals natural log of 3. We just type that in our calculator. Natural log of 3, give or take 1.10. It's that simple. Okay. These are a little more difficult, so I'll do some of these together. Again, here in B, e is already isolated, so I'm going to take the natural log. Okay. Natural log of e to the negative x equals the natural log of 35. Well, those two will cancel. So then we have negative x equals natural log of 35. Divide both sides by a negative 1. X equals negative natural log of 35, which if I type that in ever so quickly, that gives me x equals negative 3.56. Okay. C and D are a little more complicated because here E was isolated. Here E is isolated. Down here, not so much. So what do? I divide both sides by 72 to start to isolate my e to the x. E to the x equals 5. Now I take the natural log of both sides. Okay. Natural log and e cancel. X equals natural log of 5, or in our case, give or take 1.61. Okay. Same deal here. Don't panic, you're not at a disco. 300 divided by 12, make sure that my mental math is on point, gives me e to the 8x equals 25. Take the natural log of both sides. Natural log and e cancel. I'm left with 8x equals the natural log of 25. Divide both sides by 8. Okay, so what does x equal? X equals natural log of 25 divided by 8. Again, you can type that right in your calculator, pretty much the exact same way it looks. It gives us x equals 0.40. Okay, I know those are harder, that's why we did that together. Again, why do we care about e and natural log? Because we're leaning towards continuously compounded interest. Well, what this is a basic interest helps if you can spell, Mr. Herr. Basic interest used by questionable loans. So the reason I say questionable loans is if you realize a loan is working against you and it has continuously compounded interest, that means your money is always working against you. We don't want that. Now, if you can find an investment that has continuously compounded interest, you're really doing something amazing. You want to run with that investment. Okay, we'll define these variables, and we'll do one of them together, and then we'll go. Okay, A, this is an account balance after all your interest is accrued. P, this stands for principal. That means your starting amount. So how much money you started with. Okay. E is that same E that we've been dealing with, so I won't define that. R is our rate, but it must be as a decimal. If you don't convert it to a decimal, you won't get any of these right, no offense. And T is time in years. Okay, so let's do letter A together, then we're wrapped. You open a 401k account with $10,000, averaging 8% return, compounded continuously. So we're going to use this formula. You left that money in the account for 20 years. What would your new balance be? Okay, so this is known as PERT. We'll substitute what we know. Well, we know we start with $10,000, check, to e to the 8% as a decimal, that is 0.08. So this will be to the 0.08 power times 20. If we write it properly, like so, we can type exactly what we write. What I mean by that is 10,000 e to the 0.08 times 20 power. Woo, you end up with $49,530.32. Jeez Louise, I want an account like that. Unfortunately, most of our investments don't use continuously compounded interest, but sometimes, like I said, sketchy loans do. Yeah, please fill in the rest of this page. Again, I'll kick the key to page 136, 137, 138, and 139, making sure that I'm not... Nope. Maybe I'll just do 137, 136, and 138. Because 139 is new stuff. All right. Have a great day. See you later, daters.